Hello, dear authors and invited guests. Welcome to the technical session courses. Good morning, good afternoon, everyone. It's my great pleasure to welcome you to the 5th International Conference on Information and Communication Technologies for Intelligent Physical Tools on behalf of ICTIS 2021 and Global Knowledge Research. We are thankful everyone to present on this digital platform to make this conference more. During these unpredictable circumstances of COVID-19, we wish everyone and their families a protected time and we will keep it positive. I hope you will enjoy these knowledgeful and reflective sessions. Now, I would like to introduce our two session chair of this session, Dr. Priti Parvekar. Hello, madam. Dr. Priti Parvekar. She is an associate professor in computer science and engineering department at NCR campus. She has 18 years of experience in the field of education. She is expertise in Java data structure, wireless and network, Internet of Things, cloud computing, software engineering, and also a life member of CTM, IEEE, and CA. And our second session chair, Dr. Sunil Sandhu. He is a professor in computer engineering at the Field College of Engineering, Pune. He has 20 years of teaching experience. His areas of interest include network security, data management, computer organization, mobile computing, software engineering, and project. Welcome, sir, madam, to the session. Hello.
Thank you, Disha. Yes, Disha. Thank you so much. Hello, Sunil sir. This is Preeti this side.
Now we will start with our papers. I have a special note for the presenters. We will be given 8 minutes for the presentation, and on the 7th minute, I will raise the 10th minute. And I request while the presentation is going on, other participants be kindly listening. Yes, we will start with our papers. Our first presenter, Swati Singh, might be she not available yet. Another participant. Yes, we have a participant. Yes, Sorish Parne. Hello.
Hello, yes. This is Saurash, I'm here.
Yes. Now you can start your presentation.
Okay, okay. So we are starting with my presentation. Okay, fine. I'll just share the screen 1 second.
I make you forward so you can share your screen.
Share.
You can now able to share your screen.
Okay.
Yes, are you able to see the screen? Okay, then I'll start now. So this presentation is the ICT-based announcement of scheme and taking a case.
One of you can.
In rural India. These are the authors of the co-authored with the engineering department of our Bangalore campus. Yes, can you hear?
The voice is not proper.
Sorry.
Yeah, Disha, can you just tell him that his voice is not clear?
Yes, it has some network problem, I think.
So can we just start with the next participant?
Yes, sure, madam.
The next presenter, if he's ready, we'll start.
Asal Fernando. Hello.
Hello. Yes.
Yes.
Shall I?
The presentation because he has some network issue.
Okay.
Yes, there are some network issues over here. It's cutting all the time. Can you do the next presenter? I'll try to connect from some other place.
I hope you can see my screen.
Yes, sir. It's clear.
Yes.
You may proceed.
You can continue.
Okay. Okay. So I will start. So, hello everyone. I'm Hassan Fernando from Informatics Institute of Technology, Sri Lanka, which is affiliated with University of Westminster, United Kingdom. My presentation is about a survey of single image deraining in 2020, and my paper ID is 674. This is the agenda of the presentation. I will be talking about the purpose and the focus of this survey, research problem, domain, existing works that have been done in the domain, limitations and gaps that still exist in the domain, and the possible future works. Purpose of this survey is to explore existing works on single image deraining to identify limitations, research gaps, and to work out future works that are possible in the domain. Focus points of this paper are single image deraining, computer vision, and image synthesis for translating images. Disturbances from rain streaks in the vision systems of self-driven cars or any pedestrian detection systems could often be a matter of life and death. Rain streaks also affect the accuracy or the performance of many action or object detection and person re-identification systems. Also, this rain streak noise could cause quality loss on video coding and image coding as well. The problem of the rain streaks is addressed within the domain of deraining, where obstructing rain streaks are removed from an image or a video. Visible in this slide is an example for single image deraining. This is a concept map which I came up with for the domain of deraining. There are two main categories in the domain of deraining, which are video deraining and single image deraining. As this survey is on single image deraining, it has mentioned four main aspects of the domain, which are existing works, technologies, evaluation metrics, and limitations. Mentioned existing traditional and deep learning works are surveyed in the paper. Existing works were based on three main criterions, which were novelty, performance, and the credibility. Performance was measured using two main evaluation metrics, which were PSNR and SSIM, considering two datasets, RAIN100L and RAIN100H, which were both synthetic datasets used very commonly throughout all traditional and deep learning works in the domain. Traditional approaches for deraining are not used often these days, as deep learning approaches seem to perform much better compared to traditional approaches. But two credible, novel, and better performing traditional approaches were surveyed. Work 1 used simple patch-based priors on both the rain streak layer and the background layer, which are formed on patches learned using Gaussian mixture models to detect and remove rain streaks. This proved to be effective than methods which were based on low-rank constraints and dictionary learning. Work 2 produced an image decomposition framework with the assumption of a low possibility of a correlation between rain and background in rain images. This had better results with reduced over-derained effects compared to other traditional approaches which were used in the domain. Next up are the deep learning works. Work 1 introduced a deep CNN architecture which was hinged upon residual learning, focusing on high-frequency details of images. It managed to effectively avoid background intrusion by focusing on high-frequency details. It made a difference in deraining by proving that deep learning approaches are far more robust than traditional approaches. Jordan introduced a novel multitask deep learning architecture which used a binary map consisting of rain streak and background layers to identify rain streaks. The network was capable of handling individual rain streaks as well as rain streak accumulation, which is an occurrence optically close to fog or mist, which is caused by overlapping rain streaks. Noticing the common limitation in DetailNet and Jordan of using a single network to perform both rain detection and removal, DIDMDN introduced a densely connected CNN architecture. This was capable of automatically determining the rain density using the residual aware classifier, which was built separately. It was effective in getting rid of over and under the rain effects in outputs by using this separate classifier. IDC GAN explored the effectiveness of conditional GAN for image deraining, which was originally introduced for image-to-image translation in general. This network consisted of a densely connected symmetric generator and a multiscale discriminator. It managed to maintain the visual quality using an optimization function during the deraining process. Hence, it resulted in not doing any additional post-processing to enhance the images. MSPFN introduced a multiscale progressive fusion network which used a pyramid representation to uncover correlations between rain streaks. The network was divided to 3 main modules to successfully extract multiscale information of rain streaks in a cooperative approach and to construct an image identical to the rain-free image. Predicted rain streak distributions from the network were proven to be more correct, and it performed well in experimental real-world scenarios as well. CVID constructed an image deraining network using the generative ability of the conditional variational autoencoder. It consisted of a module which created a rain density map for each rain input and used a channel-wise deraining scheme to analyze different color channels. This network was built to produce multiple corresponding derain output forecasts to obtain a better performance. Centurial introduced the semi-supervised translearning approach to do single image deraining to model transitional latent spaces. This used a non-parametric method to use unlabeled data for training. It created a pseudo ground truth image to unlabeled inputs. With the help of that pseudo ground truth image, unlabeled samples were supervised to be utilized in training. AI again brought in feature-wise disentanglement, a novel and a distinct perspective to single image deraining by disentangling the rain image into rainy latent space and a background latent space. This was done using a GAN framework which followed a two-branch architecture. AI again sets the state of the art in SSIM and PSNR metrics for deraining images from RAIN 100L dataset and RAIN 100H dataset in 2020. There are several limitations that can be seen in the domain. No matter how much the results have been improved, even the models which set the state of the art have some problems with residual rain streaks left in derained outputs. This is occurring as a result of limited rain streak feature detection in models trained on synthetic paired training data. Also, when models overprocess the images, blurry output images or over-derained effects tend to occur. As a result of overprocessing, there are occasions where important background details are lost after the deraining process. When images are derained using generative models, sometimes there are unexpected artifacts occurring in derained images as well. A common limitation seen throughout almost all the works in the domain is that these works are restricted to use manually synthesized paired raining datasets which contain less natural rain streak features to train models due to the unavailability of paired natural image data. Based on these limitations seen in the domain, possible future works are defined. There is plenty of room to improve models on the aspect of over and under derain effects with the target of removing residual rain streaks in outputs by improving rain streak feature detection. It is a possibility to work on getting rid of residual artifacts in the generated outputs as well. One of the most important future works could be named as extending single image deraining to use unpaired training data. That will not only improve rain streak detection by utilizing natural training image data, but it will also take away the expensive requirement to collect natural paired image data. Simplifying the existing algorithms and system architectures to produce performance-wise efficient and robust systems is also another possibility. These were the references that were cited throughout the slides. And that is the end of my presentation. And thank you very much for giving me the opportunity to present and my findings and to listening to it. Thank you very much.
Yeah, nice, Hazel. Good presentation. Could
Thank
you hear me? Can you hear me, Hazel?
Yes, I can hear you.
Okay. So it was a nice presentation, and I think, as I understand, it's a survey paper. Am I right?
Yes, it is a survey paper.
So in this survey paper, can you just tell me like how many papers have you read?
There were many papers that I read, more than 15, but out of those, I have scoped down to the most novel. There are two main approaches for this deraining, single image deraining. Those are traditional approaches and deep learning approaches. So earlier days, these traditional approaches have been tried, and when deep learning works were introduced, those performed much better than traditional approaches. So I have taken two traditional approaches which perform the best, and rest of the 8 I have surveyed within the paper are deep learning approaches. And these papers were chosen based on scope down to the paper based on the credibility, novelty, and the performance of those works.
So did they use any neural network or convolutional networks?
Yes, there are several approaches which approaches which use the convolution neural networks, such as detailed net. It used the CNN architecture which based on residual learning to learn the high frequency details of brain images. And also there's this Jordan network which used the multitask deep learning architecture, which used a binary map to recognize brain streak layers. And also the DIDMDN, which is again another CNN architecture, which also used a separate classifier to identify the range densities in these images.
Okay, see, as I understand, there will be always a problem with the deraining. If the deraining strengths are the part of the image, then it is really very difficult to remove that particular part of the image. So have you come across this kind of study in your survey papers? And if yes, then what method did they use for that?
I couldn't understand your question properly.
See, if the derain strike is a part of an image, I mean, if it any kind of object, if I understand, if it is for driving, you are trying to improvise or you have surveyed it. So if I am driving and if it is raining, and that rain drops or a part of a rain is on my object also, it's on my car also, then it will be difficult because you are considering it as an entire image, but you have to take out separately the object in that particular image.
Yeah, so in the vision of self-driven cars or those kind of vision systems, usually what is used is video deraining. So in this single image deraining case, particularly a single frame is used to process single image deraining process it frame by frame. So like video deraining can use temporal information that is there in videos from other frames in order to derain the whole process, the whole video. But single image deraining actually have only one frame to deal with. So in that case, single image deraining is considered far more challenging than video deraining. Because of that, it only has a single frame to deal with, and the lost background information, it actually has to use its generative ability to recover that information. So single image deraining actually can be used in video deraining as well, because it can process each frame on its own without using any sort of temporal information. So, and from denoising, this deraining domain has been, it can be considered as a subdomain of denoising, because this deraining is considered separately because of the varying features, shapes, and different types of characteristics these range streaks have. Because like there are some works which are defining different types of characteristics based on the capturing the distance from the device. There, because of these varying features, this has been considered a separate subdomain in order to process these images. So about your question, you asked
All right,
whether...
Hassan.
Okay,
All right,
okay.
it's good. And in future, I would suggest you that you can start with the implementation, or you yourself can implement an algorithm for this. All
Yes,
right.
there are.
Yeah.
Okay.
So this is
Okay.
all from my side. Sunil sir, if you have any questions.
No, ma'am. You have covered each and every aspect.
All right, and then I would request the next presenter, to please share the screen, and Hassel, you please stop sharing your screen.
Yes, I have stopped already.
Yeah, thank you.
Yes, our next presenter, Libin Thomas. Are you there?
Hi, good afternoon. I'm here.
Yes. Now you can start your presentation.
Is my screen visible to everybody?
Yes, Libin.
Thanks. Good afternoon, everybody. My name is Livin Thomas. I am a PhD scholar at Christ University, Bangalore. So today we'll be talking about combinatorial handoff strategies for spectrum mobility in ad hoc networks. This is a review that we've been covering for the past 6-7 months. So what we are trying to do is, when we talk about mobile ad hoc networks, this involves a lot of mobile devices or standalone devices that get connected to different networks. So what happens is when there is poor coverage or when a mobile device moves out of its coverage area, it will have to switch over to another network or maybe another base station. So we have this concept called as handoff that comes into the picture when this switching takes place. So we are trying to focus on that aspect of networks. So when we talk about mobile ad hoc networks, we are focusing on vehicular ad hoc networks because this involves devices that are much faster and have higher mobility rate. So we are trying to optimize this handoff operation for vehicular ad hoc networks. So one of the premium examples of how vehicular ad hoc networks works is connected vehicles. You know, the new concept where different vehicles connect with each other wirelessly so that they can share information or they can share their entertainment systems and all of that. And the research, in fact, there are multiple organizations that have been working on connected vehicles that include Google, Tesla, or Ericsson, and so we are trying to, optimize network coverage for such connected vehicles. So when we focus on mobile networks, the existing methods have protocols that have a fixed spectrum allocation method. So what happens is they are very rigid, so they are not flexible. So sometimes if one channel gets assigned to a particular user, then if that channel is no more available, this user will still have to spend time waiting on that particular channel to get connectivity so that he can start transmitting again. This leads to multiple issues such as handoff delay, latency, and very low throughput and all of that. So this, in this regard, we speak about cognitive radio networks. So cognitive radio networks are those networks that are capable of automatically selecting different channels based on the usage of the different devices. So if there is a particular channel that is not available for a user, it will sort of block that channel so that nobody else tries to access that. So in cognitive radio networks, the entire aspect is, or the entire users are divided into primary and secondary users, where the primary users have access to licensed channels, whereas the others can use all the other unlicensed channels. So whenever there is a licensed channel that is free or it is not being used by a primary user, the cognitive radio has the ability to assign that to a secondary user so that the spectrum is not wasted. So this is the basic working of a cognitive radio network. We have two licensed channels and an unlicensed channel, and there is switching happening between these channels whenever there are less number of users. So the functions of CR is basically divided into four: spectrum sensing, decision making, sharing, and mobility, in which we focus on the mobility aspect of it. However, these functions could also interchange when we talk about different aspects of optimizing networks. Right. So in mobility, we have this concept called as handoff, and the handoff is um, uh, generally categorized into three parts, which is the proactive, reactive, or hybrid handoff. And there is also another classification called as no handoff, which decides if a channel is good enough for switching or not. So one of the uh, uh, best type of handoff is probably hybrid, because it, based on the demand for channels, it will switch between a reactive handoff and a proactive handoff. Okay, so in this paper, so our entire research or the entire survey was divided into multiple parts. So it involved the use of, or we tried to review papers that made use of ANN, and we made use of papers that did not, that made use of one single method, or we also categorized methods that worked on proactive, reactive, and fuzzy, and so on. In this paper, we speak about methods that make use of two or more methods. So, for example, if it is a combination of multiple attributes, decision-making methods, and ANN method or fuzzy logic method, it is a combination. So this is what we are looking at here. So this research is part of a bigger project. So we are in the initial phases of it. So we have covered only the review as of now. So we found some of the methods that were used in combination with each other. So some of these were MADM, fuzzy logic, queuing models, and so on. So MADM is a multiple attribute decision making method, which makes use of multiple attributes of a particular network. For example, it could be latency, it could be throughput, it could be delay, and it considers all of these attributes to select a particular channel at different points of time. So, and there are multiple MADM methods called as TOPSIS, SAW, and GRA, and so on. So what they essentially do is they try to get the best score for a particular set of parameters, and they rank the channels, and these channels can be selected. Fuzzy logic includes multiple values. Instead of using a Boolean set of values, it makes use of values in between. So it could either be or not be, or could be there in between, and so on. So such kind of values are used. Queuing models, essentially how queue works. So they categorize the users based on their priority, and they have multiple queues, and the queues are then picked based on the priorities, and then they are given access to the channels, and so on. And we also have common control channels, which is one particular channel in the entire bandwidth that acts as a controller for all the others. So I just speak about what these methods are, and then move on to the parameters.
You have last 1 minute for your freedom.
Sure, I'm almost done. Thanks. So these are the parameters that indicate the performance of these methods. So most of these are focusing on handoff delay and the service time. But what we figured out was that if you could somehow focus on reducing the number of handoffs, or if you could somehow focus on energy efficient methods, it would be an addition to the existing system. So that is what we have arrived at. So we have also noticed that MADM methods provide the best answers or best solutions to selecting proper channels. And if we could work on an energy efficient method, it could help in the future when we talk about connected vehicles, and when we talk about sensors that have very limited amount of computing power. Thank you.
Yes, Lipin.
Hey, ma'am.
Yeah. Good work, good presentation. As I understand, this is also a study kind of thing you have done, a comparative study of this.
Yes, ma'am.
Could you just go your slide number 11? Yeah, these parameters what you have listed. So are these parameters are used because you were somewhere talking about optimization of a network.
Right.
So these parameters are used with reference to optimization of a network, or these parameters are used in regards to something else?
Okay, so these are the list of parameters that the different proposed methods make use of. So they claim that these provide optimality to the selection of channels. So it how it provides optimality is that it is not controlling the entire network. In fact, it is just focused on a particular aspect of network where it selects the channel. So the selection of channel is improved, and that is where the optimality comes in. So they are talking about optimizing the selection of channels and not the entire network.
All right, but my part is not clear. Like there are two things. Like you are optimizing a network. That's one aspect, and one side is a selection of a channel. So these parameters, what you have listed, are they for selection of a channel, which are contributing towards the optimization of a network?
Yes, yes, they are for selection of channels. Yes, yes. In the end, these
So
are.
could we include LQI in that, which is called as a link quality indicator for
Oh,
signal
right,
strength, as
which is signal strength. Yes, ma'am.
right,
Or RSS and.
like we consider a RSSI, like you have received signal strength, so we can also have a link quality indicator for the selection of the channel, as per my opinion. All
Sure.
right.
Thanks.
Good luck for the future.
Thanks, ma'am.
Yes, Libby, just go backward with your parameter. You are concerned. Yeah, this one.
Yes, sir.
Next.
This one, sir.
Previous. Yeah, this one. Next, please. No. Next.
Up again, sir.
Next. Next slide. Yeah, this combinatorial. Previous to this one.
Okay,
Yeah.
this. Okay.
So you are considering about improves the performance of more than one parameter. So which parameter you are going to consider for the improvements? Here you are talking about some parameters.
Right, sir. And I am talking about the methods and what they claim to develop.
Yeah.
So they are saying that they can improve the performance of more than one parameters, and that includes these. So these are also the selection parameters as well as what they are trying to improve. So
So you are having some benchmark values for all these parameters, and
no, sir. There are no such benchmark parameters. The existing standard is the benchmark that we have. So we are trying to improve that. So yes, so when we talk about connected vehicles, we have different types of services. We have video service, best effort service, voice service, and so on. So when these services involve, these also involve very physical devices. So what we are trying to achieve is we are trying to reduce the number of handoffs that are required. So for that, we might require the number of hops from different base stations. We require information about where the vehicle is moving towards so that we know the location. So based on location, we can predict which are the base stations that can be selected. And we also have to reduce the number of handoffs that take place. We also have to reduce the energy. So when we talk about energy, we are implicitly reducing energy by improving parameters such as delay and throughput. So when the processing is lower, it also automatically reduces energy is our understanding of the concept. So we are trying to include MADM along with ANN or machine learning techniques, but we haven't reached that far as of now. We have only spoken about MADM and CR networks.
okay, thank you, and best
Yes,
wishes
sir.
for your future work.
Thank you, sir. Thank you very much.
Yes. Thank you, Lily.
Thank you. Shall I stop sharing?
Now we have another presenter, Greening Voice, Tanzania, paper titled Compressed Sensing MRI Reconstruction using Combinatorial Dictionary Learning and 16th year. Hello.
Yes,
Anyone?
ma'am. Am I audible, ma'am?
You can audible. Now you can share your screen.
Okay, ma'am. Is my presentation visible, ma'am?
Yes, visible. Go ahead.
Okay, ma'am. A very good afternoon to all the dignitaries and my dear colleagues present here. And I am Rinmoy Sandila from Guwahati University, and hereby presenting on compressed sensing MRI reconstruction using convolution dictionary learning, CDL, and Laplacian Triad. So I have summarized my presentation into following categories. I would start with a brief introduction to the field of the research, a little bit of background behind, a problem statement, and a proposed solution. Then I shall move on to explain methodology in brief. This will be followed by results and conclusion. So in to begin with, MRI is a very popular tool because it is radiation free, it is non-invasive, and it can image both soft and hard tissues of the body. But it has also its fair share of limitations, like there is a long data acquisition problem which is associated with MRI. There are breathing artifacts. There are the myriad types of noise profiles that are associated with MRI, like Hessian noise, Gaussian noise, Rayleigh noise, etc. So as for solutions, I will concentrate on sparse reconstruction methods basically, because my technique is also related to sparse reconstruction technique. There are some techniques, and there are some limited amounts of measurements taken in sparse reconstruction techniques actually. So there are some parallel MRI methods. As for noise and artifacts, reducing noise and artifacts, there are different priors. Like there are total variation prior, BM3D prior, and some machine learning algorithms as well has come out nowadays using neural networks. So there is a mathematical setup. We will briefly provide a mathematical setup. So here there is an unknown signal X and some available measurements Y, such that it follows that formulation Y equal to AUX. So AU is an undersample matrix. It's rank efficient matrix. So there may be an infinite number of solutions to this kind of problems. So as for solutions to this type of problems, we are having some greedy algorithm methods. There are some other methods as well. Basically, we have one prior information in hand that our X will be sparse, or in X there will be very less non-zero entries in some transform domain. We have to find that transform domain. Basically, we choose that transform domain. So we use some L0 norm to find out that particular solution. So L0 norm may be NP hard also, non-polynomial time hard. So we will incorporate some other norms as well. There may be L1 norm, there may be L quasi norm. So this type of problems can be attempted to be solved with this kind of setup. So here the same problem formulation I have shown as an optimization function. There is a minimization term. There is psi here is a transformation matrix that will make this whole thing sparse, and we will try to reduce the L0 norm so that this satisfies this type of equation Fux equal to y.
Sorry to interrupt you, but you can zoom your PDF.
Zooming the PDF, okay. Is it visible, ma'am?
Can you full screen your PDF?
Yeah, so sure.
Done. Now you can do.
So I have subdivided the methods into fixed basis and data adaptive. Fixed basis, there may be curvelets, wavelets, contourlets. So wavelet may not represent some edges and curves in the data, that may be represented with curvelets and contourlets. In data adaptive, we have deep learning methods and dictionary learning method. And in dictionary learning method, there is a very popular method, convolution dictionary learning. There is DLMRI, this is also equally popular, and online CDL. So all these methods uses L1 and L0 minimization problems, the type of problems we have discussed. So coming to slide 6, I have given some basics throughout to the problem at hand. So here the first term attempts to minimize the difference in data between the reconstructed and the original. D is the dictionary. D is the dictionary learned, and alpha j is a set of sparse coefficients. And so it's a data consistency term. It will ensure that the data reconstruct is consistent with what we require. Lambda is a trade-off constant between efficiency and data relevancy. And as discussed, L0 norm minimization has been reduced to L1 minimization. So this will be followed up until this particular constraint has been met, that the summation of D should be less than some kind of a threshold C. So this type of equations is like solving two least-squares problems on either technique. Once we find the sparse coefficients, then in the second step we will update the dictionary. So it will go on like that. Okay, now the issues present in this type of general setups. So as discussed before, X is noisy here basically. So trying to create some noisy information may affect the training of the dictionary, and also our problem. The second problem may be that we will require some overcomplete dictionaries to incorporate everything, every variation in X. So it's a noiseless data anyway, so it may not be optimal. We may not have some computational efficiency such as this. So our problem statement is to is straightforward, is to sort for some appropriate prior processing step to send the actual essence of the data, not the noisy one. So we try to formulate a hypothesis here. So in order to incorporate prior pre-processing, we have introduced a Laplace Triad in this paper. So this is designed to operate on a basis which is actually a set of eigenvectors of the Laplacian graph. So we will have some steps to obtain a Laplacian graph of the image, and we will have some eigenvectors, and those information will be incorporated into that minimization problem we can. So these are some methodologies how to find out that Laplacian prior. First of all, we will find a nearest neighbor graph G, which is formulated with, which is defined as if there are two feature vectors fi and fj, then this is a nearest neighbor if they are connected. So connectivity, there are some standard definitions for connectivity. There may be some 4 neighbor, 8 neighbor connectivity. So those will apply. Then in rule number 2, we will find a weight matrix. What we will do if these two set if vectors yi and yj are connected, then there will be some non-zero weight, otherwise. So finally, we will formulate this Laplacian matrix L, and where I is a identity matrix, B is a diagonal matrix, capital W is the same weight vector which we formulated beforehand, and this will be incorporated into the final set of equations. So the only thing changing here is instead of X, we are changing it to this rho is a yes. So now not the noisy data is going into the system, but in essence of the data, a true information of the data is going into the system to the training of the dictionary. So it will not be as redundant as before.
Sorry to interrupt you,
Yes,
but we have last 1 minute for your presentation.
yes, ma'am.
Hello,
Yes, ma'am.
you are not audible.
Ma'am, am I audible?
Yes,
Okay, ma'am. Okay. So I have discussed some results here. The first image is the original plus noise. So noise has been incorporated before. So I have shown two methods here, reconstruction by two methods. One is BPDN, basis pursuit denoising, and one is our proposed method. So as we can see, in BPDN reconstruction, the reconstruction tends to smooth out. It will miss the edges and curve information in the data. So it doesn't have much information actually. So in the proposed method, as we can see that the image information has been retained successfully. So this is a performance comparison between the basis pursuit denoising and online serial and proposed. So BPDN has a very less computation time. It takes around 11 seconds, but the PSNR and SSIM is relatively less. As for conventional online serial, the computation time is very high, but there is a significant increase in PSNR and SSIM. As the proposed method, computation time is the highest, but PSNR and SSIM both are increased. Next, I have shown a graph of the functional versus the iterations. Here, I have shown how the functional is reducing with a number of iterations passed. So as we can see, the proposed method performs very well as compared to online serial. This is a ADMM graph, alternative directing method of multipliers graph. This shows the two reconstructions, primal and dual, for both X, BPDN, and our proposed method. As the last image, these two images, the first one is a initial dictionary learn. It was like in the first two or three iterations. So as we can see that there are very less information in the dictionary atoms. It resembles noise actually. But at the final dictionary, the edges and curves has been properly shown, and the features has been learned quite well in the final version of the dictionary. As for conclusion, we have shown that this Laplacian prior may be equally effective for online CDL, as well as we have shown in BPDN also reconstruction, and performance parameters, performance comparison has been made with PSNR and SSIM. Reconstruction algorithm is ADMM, but there may be some improved reconstruction algorithms also. Nowadays, plug and play ADMM has also come. There are different other algorithms as well. ADMM is very nice for convex optimization, but otherwise it may not be so optimal. So there is a future scope as compared to that. Also, for perceptual quality, we are thinking about incorporating a perceptual error afterwards as a future scope to this work. So these are the references. Thank you, ma'am.
Yes, Mike, good work. May I know what software did you use for your implementation?
For implementation, ma'am. For implementation, ma'am, we have used dictionary learning technique only. As a optimization algorithm is ADMM, and prior is Laplace.
Have you used any data set for your input?
Okay. Dataset is a functional MRI dataset we have used. There are like 50 or 60 images has been used.
Okay.
Out of functional MRI dataset that has been cited in the paper also.
Okay. Is it done in MATLAB?
It is done in Python, ma'am.
It's done in Python. And how many training data and testing data?
Training is 5 or 6 I use, ma'am, and training is 50, testing is 5 or 6.
All right. Over to you, sir.
Yes, ma'am, no questions. Please proceed.
All right. Good luck. And will you please stop your presenting your screen, and we will proceed with the next presenter. Thank you.
Yes, next presenter, Shakti Singh. Are you here?
Yes, ma'am.
Now you can start your presentation.
Okay. Can everyone see my screen?
Not yet.
Oh, okay. Okay. Is it visible now?
Yes.
Mm. Just a second. Device. Just give me a minute. It's not. Yeah. Can you see it?
Yes. Thank you.
Yeah. So the topic of my paper presentation is a comparison of 4-parameter mathematical logistic growth model with other SRGM. Hello. Am I audible?
Yes. You can.
Yeah. Other SRGM based on bugs appearing in the software. The topics that I will be discussing are these, starting with my abstract, then introduction, models that I'm using for comparison, parameters and data sets, criteria that I've been using for comparison, my methodology, and the results obtained, conclusions and references. So in this work, what we are doing is actually we are presenting a comparison of a 4-parameter logistic model with other existing SRGM models. SRGM models are basically software reliability growth models that monitor the reliability growth of softwares in mathematical form. So this particular model gives us the rate at which the function MT is changing and the quantity of growth that is remaining by a time-dependent logistic function per quantity per unit time. And they have a directly proportional relationship with each other. What we are doing with this model is that we are determining how many failures are can be expected from a software in a particular time t. This helps us in basically when we are releasing different softwares and different versions of software, it helps us in planning that if at least these particular features are fixed in a particular time, we are ready to give a new version of the software without losing on the market. So what we are doing in this paper is that we have considered 3 criteria for goodness of fit. Goodness of fit will tell us that which model is best suiting in for our particular data. And 3 criteria we are using, MSc, SSC and R-square, that I will explain later in this. So when we talk about software reliability, it is basically a probability of a software operation to be failure free when we give it a particular specific environment and for a particular period of time. If it fails in that particular period of time, then we say that software is not reliable. But as we see that in our coming time, everything we have around is in the form of software. So reliability becomes a very important asset for us so that we could have reliable softwares and we could depend on them as well. So the software reliability is the key factor that is contributing to give us more efficient software systems. Now, based on this software reliability, we have different software reliability growth models. These are basically statistical models of defect detection data, and they are represented by a mathematical function. They helps us in predicting the future rates of number of defects that are remaining in the code. And if we talk about literature, there are many different mathematical models that are available. For example, Goel and Nukumoto, Yamada model, multi-release model. And these are all based on different releases of the software, different bugs that are passed from one version to another version. Basically, 3 issues that comes in releasing of software, new software is one is that the bugs that are actually remaining in the software. Second thing is when we try to add some new features in the software, then also we are due to that adding those new features, some new bugs are introduced in that. And third one is if we are trying to improve some features, then also some previous bugs are resolved, but we tend to add some more bugs. So my basically data that I'm handling here is about bugs only that are left in different releases of the software. So the model that I have used different models in this, and the model that showed me the best result was this that had 4 parameters, that its name is PNZ. Pham et al. Introduced this 4-parametrical logistic model, and in which the rate at which the function MT is changing and the quantity of growth remaining by a time-dependent logistic function per quantity per unit time have a directly proportional relationship with each other. The basic assumption of the model was this equation 1, in which BT was per quantity per unit time of the bugs that are appearing in the software. So basically, the first assumption of this was that at time t, when the software we have not used, the number of bugs that are appearing in the software is also taken to be 0. So when we this model was designed, the final mean value function that we had for the model was, it had 2 parameters n, b, a, beta in it, and this was giving us the helping in determining that how much failures can be expected in particular time t. This model is also known as Pham inflection model. Now the models that I'm using for my comparison are Goel and Okamoto, delayed S-shaped, Pham dependent parameter, inflection S-shape, Yamada imperfect debugging, PNZ, and Pham inflection. These are the mean value functions of them. Some of these models are just 2 parameters, some of them are 3 parameters, and some of them are 4 parameters. The parameters that we are using is the first is the MT, which is the mean value function. It gives us the count of failures that would be expected in time t. N is the number of predictable faults that exist in the software initially. Initially, when the software is released, it is almost impossible to release any software without any bug. And BT is the rate of at which rate we are trying to find the fault, at the rate of fault detection. And there are other constants in this which are different for different models. And the project data that I am using is Avro project data for Apache open source software that is used. Now I'm using 3 criteria for determining the goodness of fit, whether this data fits into the models. The first one is sum of squared errors. We are trying to evaluate the performance of the models using SSE value. This is the equation for this, but what I have done is that I have used these models in SPSS using nonlinear regression of it and obtain these values, the expected results from the observed results. So this is the sum of squared errors, the mathematical function, equation 4 represents it. Another criteria that I have used is mean squared error. In this, we calculate the mean estimation of the deviation between the observed value and the value predicted by the analysis. The third criteria I've used is R square. It is simply a square of R. It gives a degree to which the input variable varies with output variable or predicted value of the variable. The better the result is considered as the value is closer to 1. The methodology that I have used in this, I have used in SPSS nonlinear regression on this data set and use different models and try to calculate MSE, SSE, and R square and then compare my results. So these were the results obtained for me for different models. And what I have observed, I have got the best results in the case of Pham inflection model, which had 4 parameters in it for this particular data. And I also observed that the value of R square is 0.995, which is closest to the 1. So basically my conclusion is that for software reliability growth management, there are different types of models, parametric as well as non-parametric. I have narrowed it to parametric models only and compared my data on these available parametric models. And I have observed that in this, the more number of parameters that we have, the model is showing the better results. And also R square being closer to 1 is indicating a very good fitness of this model. And among all the models that I have used for my data, this was the best that gave me the results. These were my references. Thank you.
Yes, Swati.
Yes, ma'am.
Yeah, I have some couple of questions for you.
Yes, ma'am.
Like when you are testing the software reliability.
Yes, ma'am.
Okay. तो जब हम सॉफ्टवेयर टेस्टिंग करते हैं तो रिलायबिलिटी उसी का पार्ट है, तो आपको अलग मॉडल्स लेने की क्या जरूरत है?
Sorry, ma'am, I didn't get your question.
Software testing subject you have. I mean,
yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am.
is a part of it when you test a
Yes, ma'am.
software. So other than that, हमें models
Yes.
की ज़रूरत क्यों पड़ती है? I mean, why did you
हम
take that?
actually in models के through हम reliability growth भी study करते हैं, that from different versions and different data, that how is reliability growing from one version to another. These
So that is
mathematical
what I'm
models.
asking you, that what is that part which is left in the testing, because of which I need to take the help of this mathematical models.
Basically, these models can help us in making a decision making. They can help us in having a, for example, if we have this question in our hand that should we wait for a particular number of features to be fixed, and supposedly if that time is for 2 months and other software comes in the market because of that, so we lose out on the market just trying to fix those features. So we have to make this decision whether we should give it time or whether we should try to just fix some features and then release the model. It helps developers in making these optimal cost decisions and release planning of the software.
How will you decide the growth of a software? You have mentioned in your this thing that these models are used to measure the growth of the software. How
Yes,
are you
ma'am.
measuring the growth of the software? It's really difficult to measure the growth of the software. So if there are certain parameters, then yes. But if you are talking about the reliability, then you have to fix it. And if you are talking about the growth, then you have to mention that what aspect will measure the growth of the software.
Yes, ma'am. It is actually we cannot quantify reliability, so
That's
that
the
is why
problem.
that is why we use these models, so that we could have at least a mathematical idea of
The things what you are talking about is a non-functional requirements. Like we have a functional requirements and non-functional. So if you're talking about non-functionality requirements, so this you don't have any quantity, so it's difficult to measure. And the next question I have is, you are deciding that which model is best. So what are the parameters that you decide? Okay, this model is best than the other model.
No, I'm not deciding. Actually, I've taken some models on my data set, and I have got this result that this particular model is fitting the best.
So what was that parameter where you have decided that this model is best?
Basically, I have calculated MSc, SSC, and these are the criteria to find which model is suiting best. And my results were the best for the this particular model.
That will be
Time
mean
inflection.
square error what you have calculated.
Yes, ma'am.
All right.
MSc, SSC, and R square.
Okay, sir. Thank you. Good luck.
Okay. Thank you.
Swati, I would like to ask you, you have think about the agile methodology of this.
Sorry?
Agile
Yes, sir?
methodology
Agile method.
for this your work.
No, sir.
Okay.
This is just a comparative work. I would like to work on actually modifying or building a new model for reliability growth.
So you have to try with the agile methodology also, which is
Okay, sir.
definitely going to give the improvements in your existing things.
Okay, sir. Thank you so much.
Okay. Thank you.
Yeah.
Thank you, Swati.
Yeah. Thank you, sir.
Our next presenter, Ruchi Chan. Hello.
Yes, ma'am. Hello. Am I audible?
Yes, yes. Now you can start your presentation.
Just a minute. Is the slides visible? I'm Ruchi Chanu, and I'm here going to present my work, which is based on building a recognition system for Manipuri handwritten digit system by using Hawk-assisted deep learn features. is the outline of my presentation, introduction, objective of my work, proposed work, followed by experimental results and discussion, and future work and references.
Sorry to interrupt you, but you can full screen your presentation.
Yeah. Okay, now. So in my paper, it is based on building Manipuri Meitei Meg is the official language of Manipur state. We are trying to develop a recognition system which can recognize the handwritten Manipuri digit system automatically. So this optical character recognition has become a very interesting research area nowadays, and it has become one of the most promising and helpful strategies for human-computer interaction. And we can see that the text data stored in the form of handwritten documents is very important and beneficial, as they can be used for future references while keeping records for events, culture, or literature or history. But automatic handwritten OCR has also entered the area of large-scale application, with the growing interest in mobile information, gadgets or devices like the cell phones, tablets, and other handheld computers. The main challenge that we face nowadays in automatic recognition of handwritten script is that we have to encounter with large variety of variations in the styles of handwritten scripts, because this has been written by many people. So characters from various writers, they are very much different in terms of shapes and sizes. So because of this, this makes the tasks of recognition more difficult. So we are aiming to integrate the machine learning algorithms, which has been widely used for feature extraction and classification of images, into this area. Artificial neural networks is also a common technique for classification and the recognition purposes. This is because of their good learning capability. So in our work, we are going to use the artificial neural network subtypes, that is the Hawk assisted deep learned features, which has been integrated with the multi-layer perceptor neural network for recognition. Main objective is, first we create a dataset of handwritten Manipuri digit characters, and after that we learn those characters and develop a recognition algorithm for handwritten Manipuri digits. So figure 1 represents the Manipuri digits. In Manipuri language, this Meitei Mayek is known as the original Manipuri scripts. And figure 1 represents its original script with respect to the English digits. In our current work, as I have said, we're going to develop a classification technique of this Manipuri Meitei Mayek digit system based on the histogram of oriented gradient assisted deep learned features, which has been trained by the MLP, multi-layer perceptron. After that, features extracted from Hawk descriptors will be given as an input to the multi-layer perceptron, and they are trained, and these are used for the recognition purposes. Before we go through this, all the input images that we are going to take will be undergoing a pre-processing stage of for removing the noise, and they will be extracted individually. Then after that, the images will be passed to the Hawk descriptor to extract the features vectors, and the extracted feature vectors from the Hawk are trained and recognized by the MLP. This is the our proposed model, which has been designed in 3 steps. The input images, they are going to be extracted, and then they will be fed to a, as you can see from the diagram, the proposed work assisted deep learned features will be obtained from the second step. And see, the purpose model starts with the extraction of these input images from the HOG, and it is followed by the process of deep learning using the MLP. HOG is a feature descriptor which is commonly used in image processing for object detection. So in our work for classifying this Manipuri Meitei Mayek, we use this HOG feature to assess deep learned feature extraction, and which can be used to discriminate the different shapes or structures of the given images to differentiate every character clearly. In our work, we have tested over a data set of 10,000 handwritten samples. These data sets are collected from different schools and colleges, as well as some clubs also, and they belong to these handwritten data sets are written by different people. These different people, they belong to different age group as well as different professions. Some are from the primary school, some are from the intermediate school, and some are from the colleges. So we can say that data sets includes variety, have different shapes and structures belonging to different age group as well as the profession. So we can see this figure 3 depicts a sample image from the data set of handwritten Manipuri Meitei Mayek used for this experiment. Now in the training set, as we have seen, training set consists of these sample images for learning this neural network. So we have collected 1,000 samples for each 10 digit 0 to 9, 1,000 samples for each 10 digits 0 to 9, out of which 999 samples, they are used for training the neural network, and the remaining 100 samples each, they are used for the testing purposes. The test data set is used for the evaluation of the generalization of the proposed system to the unseen data. And after we fit this, we can see table 1 gives the confusion matrix of the Manipuri digit 0 to 9. So some are having some accuracy of 99, some like numeral 1 is having correctly identified 100%, whereas some digits like the digit 5 miscorrection 1% is there, and some digits like digit 8, digit 9, they are also having some miscorrection ratio 2% and the 3%, as can be seen from the confusion matrix.
Sorry to interrupt you, but you have to go with your conclusion.
Hello.
Hello.
Yes, ma'am.
We have a time limit, so now you can go with your conclusion, please.
Okay, fine. So this is the accuracy of the proposed work. We have some correct ratio and we have some false ratio also. As you can see from the table, the digits 1, 2, 4, 6, and 7, they are having accuracy of 100%, whereas the rest of the digits, they are having some false rate of 1% each. And table 3 gives a comparison of the same proposed structure with 2 different methods. One is histogram oriented gradient plus with the multi-layer perceptron, and one is with the MLP only. So you can see accuracy is higher in case of Hawk plus MLP structures. This is the comparison of our work with the current already done work, and our proposed work is having an accuracy of 99% as compared to some other works which is very higher, which is higher in our case. There is a small limitation is that we need to find an optimal size of the Hawk block feature for recognizing the Manipuri Meitei characters efficiently. And we have to search the Hawk cell size, like just 6x6, 7x7, or 8x8. This we have to manually run and select an optimal size, which gives you the maximum efficiency. Conclusion in future work, maximum accuracy received can be 99.2, which is higher than other methods. And we are aiming to extend our recognition of this text for degraded text also. Here are my references. Thank you.
Yes, I have just one question for you, that how have you collected your data?
Actually, ma'am, I have distributed, me and my partner had distributed and asked some school children, some college going people, and in clubs also, some society also, just to randomly write the numeral on a white paper, A4 size paper, and we have collected in that way only, our friends also and their friends also. We asked them to write the Meitei visits on A4 size, and then we collected.
Okay, so that's a good thing. It's a real data, what you have collected from the different age groups.
Different age group and different people with different profession.
Oh, that's excellent. Just a small suggestion, if you have collected, because see, we are lagging in collection of a data. I mean, we generally go for a ready-made data sets which are there. So since you have done a lot of efforts, so you can always make your own database where you have,
Yes, ma'am.
Yeah, you can put it on the internet for future.
Yes, ma'am. Yes, ma'am. I will do that.
Good work. Thank you.
Thank you.
Suresh sir?
Yes, ma'am. No questions. It's really good. Real-time data set they have collected. It's really good work.
Thank you, sir. Can I stop sharing?
Yeah, please stop sharing and we'll proceed with the next presenter.
Our last presenter. Are you there?
Yes, I'm here. I'm ready.
Are you able to share your screen?
Actually, Mr. Amit can share the slides. I send it to him because we have some network issues over here. Yeah. Yes, could you go to the title slide? Next one. Yes, so the title of this research is ICT-based enhancement of employment schemes, and we are doing a case study based in a village in Uttarakhand in India. Next. Can you go next? Yeah. So this is the research team. So it's a collaboration between different departments of our engineering college. So mainly EC and mechanical, and myself, Suresh, I'm presenting. Can you go next? So just to quickly introduce, so in India, 65% of the population lives in rural areas, and unemployment rate is very high over there. So the NREGA scheme was implemented in 2006. So it's the largest initiative to address rural unemployment in Asia. But it has like contrasting results. It doesn't work the same way everywhere. And the shortcomings which have been identified are how to assess that the work has been completed by the people. And there are some delays in payment for the workers also, which results in a discouraged worker effect. That's something in literature. So ICT is recognized to be a very powerful way to address those challenges, and that is the point in this paper. So we'll try to see how ICT can improve such schemes, and we'll do it through understanding the factors which are locally on the ground, preventing the implementation of such kind of employment scheme. Next, please. So this is the study area. So we went on the field in a village in Uttarakhand, which has little more than 1,000 inhabitants. They're all farmers or doing cattle rearing. And there's a chronic problem of unemployment, and all the villagers are relying entirely on agriculture and farming. Next. So just quickly about the research methodology. So we have used mixed methods and ethnography, meaning that we went on the field over there. We stayed for a week to observe how the people were working in the village. So we did participant observation. We interviewed the farmers, members of the local self-help group, also the local authorities. Based on that, we have developed personas and scenarios as part of our human-centric method that we have used to understand what are the pain points of the people, what is their experience with working with the employment scheme, and all that was triangulated with secondary data from mostly government sources just to assess the accuracy. So as a result, we interviewed like 45 households, so that's roughly 21% of as a sample size. So we have made observation that most of the land was actually not used, and actually only the ladies were working on the field. That's the main two things. So we developed different personas to summarize the type of people and the experience with the problem of unemployment. So the majority of the villagers were all working under the NAREGA scheme, and a minority of the villagers were working on the SAG, like women mostly, and occasionally also on the NAREGA scheme. But overall, everybody was involved in the scheme at one point or the other during the year. And in terms of the stories and the experience of the people with the scheme, the scenarios highlight like a feeling of discouragement of the community because they are doing work, but they're not getting paid or it's extremely delayed. So they're not being motivated to participate in the scheme again. And we also found a lack of information about how the scheme works. And the people on the field, on the ground in the village, they have no idea if they have to apply or if they have to do this and that. They don't know anything. And authorities are also not doing much for publicizing and explaining to the people how it works. So the secondary data, as you can see in the next slide, which it shows that the average wage per people per day has increased, but the number of people have decreased. And also that the amount of work that has been assigned has really reduced since the scheme was implemented. So can you go to the next slide, please? So it shows, these are the official government data from that the district of that village in Uttarakhand. So you can see that there's on the right side, it shows that the number of people who are taking part in the scheme since 2016 is like decreasing. It started very high, but like it's going down. So that illustrates also that discouragement and demotivation of the people with taking part in that scheme. Though on the left side, it shows that the remuneration, how much they're getting, has increased, which is a bit contradictory. Can you go to the next slide? So this is our main contribution is this. So as a result of understanding where the challenges of the people, we are proposing an ICT-based solution to address this challenge. So our solution takes the form of a smart band, and that like a wristwatch that the people can wear. So that will integrate, as you can see in the bottom part with the block diagram, a module with a GPS, which can look geo in the location where they're supposed to be. And also it will have an inertial measurement unit to give all the parameters to translate all the hand movements so that we can see if they are doing the movement connected with the work they're supposed to do. And all that will go in the cloud database, which will automatically generate a report, which will be sent to the NAREGA authorities. So based on that, it won't be possible to someone to claim he has done the work and not done, because everything will be based on the GPS. We can see if he was there and if he has done the movements corresponding to the task. So all that will be connected through a smartphone, and it can be sent to the authorities. So as a discussion, what we have observed on the field is in line with whatever has been written in the literature regarding the implementation of the employment scheme. So it's a committee which is entirely dedicated to agriculture, and we can find that it's actually a textbook case of a discouraged worker effect. So the people know that this scheme, know they could get some money, but they're not interested because they have very bad experience with it, because they're doing some work and they're not getting paid. And the payment has been delayed because the officials working in the scheme in the district are not able to go to each and every place to assess if the people have done it actually. So by using this ICT system that we are proposing, we can automate and we can improve the transparency of the scheme. That's the main contribution. So the tracking system will make sure that people cannot wrongly claim they have done something, and authorities can also have a confirmation that they can release the fund to pay the people. That's the main thing. Yeah, can you go to the next one? So yeah, so this is just to conclude. So this is a very much field-based approach, where we have been on the ground to see how the things were, because if it was in line with literature or not. And we have identified some of the drawbacks of the NARGA scheme, and we are proposing some technical solutions to address it. So here we are just proposing the design. So it was before COVID, so it has been, of course, delayed, but we are developing a prototype so that we hope in the future we can test it on location in the similar village. So in the interest of time, I've been a bit quick on that. So open for any questions now.
Yeah, interesting work, Samesh.
Yeah.
And as you have seen the architectural diagram of ICT-based solutions, so I think it's just a proposal. You have not started that ICT-based solution yet, right?
No, it's the design based on a field study. So it was last year before COVID. So now we were supposed to do the prototype, but all those things are getting delayed. So next year we're building the prototype, and we want to go whenever it's possible, go there again and test with the people if it's actually working as we foresee.
So it will be like a wristwatch or a bracelet. They will wear it and go around and move around, and then you will monitor whether they are working or not, right?
Yes, exactly. Yeah, something very practical that they can easily wear, and so that for them it shouldn't
more
be
like a IoT application, Internet of Things.
Yeah, kind of. Yes, exactly. Yeah,
yep.
Kind of. Yeah.
Very nice, very interesting. Good luck.
Yes, thank you so much.
Any question from Suresh?
No, ma'am.
All right, then Disha, I guess this was the last presentation.
Yes.
So in the list, I see one more name. So one minute, let me just have a look.
Yes, she will present in next. She might have some network issues, so she will join in session 3.
All right.
Aswati Balakrishnan will.
Right. Yeah, that name is there, so I didn't see that. That's what I wanted to ask. Yeah. All right. Thank you so much, and thank you so much all the presenters for presenting such a quality work. We got to know so many things in today's session. So thank you so much, and all of you, good luck for your future work. And thank you ICTIS for making us a part of this and giving us the opportunity as a session chair. So further instructions, I think Disha can give.
Yes. I sincerely thank our authors for their excellent presentation in this session, and all our participants for being a part of this international conference. I hope this session was informative. And all the presenters would be getting their digital certificates through email within 2 or 3 days. Further, all the papers have already forwarded to the students, and the publication will be live within 5 to 6. Kindly cooperate with the team of ICTIS 21. At last, I would like to thank you, our session chair, Dr. Parwekar and Dr. Sunil Sangwesar. Here is token of your appreciation, sir and madam. This is for you, sir. This is for you, madam. Thank you for chairing the session.
Thank you, Disha, and thank you, Sunil sir. Nice meeting you virtually.
Thank you, madam.
On this platform.
Thank you. Same to you.
Request to turn on your camera for a quick.
Okay.
Kindly please all.
So are you taking a virtual photograph?
Yes. there, all of you.
So Disha, are you going to say 1, 2, 3, ready?
Once again, 1, 2, 3. Smile, please. Yes, perfect.
Thank you so much.
Thank you.
Thank you, Amit sir.
Thank you, Dr. Preeti. Actually, I am connected to 3 parallel sessions, so
I can totally understand. I know. I understand.
Very much
Thank you
for
so much.
sparing your valuable time. Thank you.
Thank you so much.
Thank you, Dr. Sunil, as well.
Thank you, Amit sir.
Thank
Thank
you.
you, Disha madam.